and Volare use the familiar blend air conditioning system, in which heated and cooled air are blended to produce the desired temperature. New design features offer important advantages to you, the service technician, like a blower motor you can service from inside the car, an evaporator which slides in grooves for easy removal or installation without removing screws, and well, we're getting a little ahead of the story, so let's start by covering the controls and other components of the system. The push-button control unit, temperature lever, and blower switch are identical to those used on our larger cars. 4 independently adjustable outlets direct and distribute upper airflow. And for added comfort, a new 3-position control lever directs a portion of cool air through the heater outlets in max AC, AC, and vent modes. Located behind the modular instrument panel are the ducts which carry heated or cooled air to the passenger compartment. The system has 2 main units, a blower assembly and an evaporator heater assembly, which are connected by an engine side housing. The blower housing contains a vacuum actuator, an air inlet door, and the blower motor. The air inlet door position is controlled by a double-acting actuator, which is operated from the push-button control panel, whose vacuum source is direct from the engine intake manifold through a check valve. Vacuum is applied to the lower side of the air inlet door actuator in the off and max AC modes, allowing inside or recirculating air to enter the system. In AC, vent, heat, and defrost modes, vacuum is applied to the actuator's upper side, allowing outside air to enter the system. As mentioned earlier, the blower motor can be serviced from inside the car. Water seals protect the blower motor, and a sound-absorbing housing enables the motor to operate quietly in all 4 blower speeds. The evaporator and heater housing is of compact, lightweight, seamless construction, which prevents condensate leakage inside the car. The housing has a new molded rubber drain tube for condensate removal, which also prevents engine compartment air from entering the air conditioning system. In order to service the evaporator and heater core, the entire assembly must be removed from the car. Mounting studs have foam seals which seal off the stud openings to the engine compartment, and sound-absorbing foam cushions are used at the bulkhead and at the heater core tubes. Always reinstall foam isolators when reassembling the unit to retain the sound quieting features. The housing lid is easily removed after unfastening the hold-down screws. On early production units, a short screw is used above the upper heater core tube because clearance between the lid and the tubes is limited. When reassembling, be sure to reuse the short screw to avoid puncturing the tube. Check the blend air door pivot socket to make sure it holds no sealing compound which could hamper the door's movement. The housing lid and walls have baffles designed to improve heating and cooling balance and airflow travel to all outlets. As air enters from the blower housing, the walls and baffles channel the airflow through the evaporator and/or heater core and through the balanced ductwork to the passenger compartment. Hold it. Don't get any ideas about modifying the walls or baffles to improve airflow. Their shape, size, and locations are designed to obtain the best airflow and distribution and should not be altered for any reason. With the housing lid removed, the evaporator slides out easily from grooves inside the housing. Foam band insulation assures quiet operation and easy reinstallation. Downstream from the evaporator, the blend air door controls outlet air temperature by diverting all or part of the airflow through the heater core. Door action is controlled by the temperature lever, which is connected to the blend air door by a cable. The heater core in this assembly cannot be removed separately, as in some other models. One short screw clamps the heater core plate to the housing. Like the evaporator, the heater core slides easily out of its mounting grooves and is also insulated from its mounting by a foam band. This all-around one-piece foam band also adds to the overall quietness of Aspen and Volare. When reinstalling the heater hoses, the top or water outlet hose connects the heater core to the engine, and the bottom or water inlet hose connects the water valve to the heater core. be sure to check the hoses for leaks if any glycol odor is noticed. The vacuum-operated mode door allows air to flow out of the adjustable panel outlets or the heat defrost outlets, depending on the operating mode. Vacuum is applied to the outer side of the actuator in the off, max AC, AC, and vent modes, and to the actuator's inner side in the heat and defrost modes. The mode door is down in off, max AC, AC, and vent positions, and moves to the up position when heat or defrost buttons are pushed. In all button positions except defrost, the heat defrost actuator holds its door in the up position. In this position, the door is designed to allow a reduced flow of heated air to bleed through the defrost outlet. When the defrost button is pushed, vacuum is released, so the door moves to the defrost position, directing airflow to the windshield area, with a small amount of bleed air through the heater outlets. The manual floor air control lever operates only in max AC, AC, and vent modes. This lever raises the mode door about an inch to allow cooled air to flow through the floor outlets. Incidentally, the lever is not loaded in the heat or defrost positions, so it is free to move loosely, because the mode door moves to the up position, directing airflow through the heat and defrost outlets. Now that we've covered the components, let's see how they operate in the different modes to control airflow. The modes are off, max AC, AC, vent, heat, and defrost. In the off position, there is no airflow, because the blower motor circuit is open and the air inlet door is closed to outside air. Now, in the max AC position, the water valve is closed. The compressor clutch engages and the refrigeration system operates. The blower draws air through the inlet door, which is now open to inside air, and pushes it through the evaporator, which cools it and removes the moisture. For maximum airflow, the temperature lever is placed in the full cool position, allowing the blend air door to divert all the recirculating air to the air conditioning outlets without passing through the heater core. The mode door seals off the heater defroster chamber, where the heat defrost door is in the up position, allowing air to flow through the air conditioning outlets. The cold air velocity can be regulated by switching to another blower position. But the air temperature in this mode cannot be regulated by the temperature lever, since the heater core is cold due to the closed water valve, and this prevents reheating. Going from max AC to AC, the air inlet door moves down to allow outside air to be drawn in through the plenum chamber, and the blower forces air through the evaporator toward the blend air door. The mode door remains in position to direct the flow of air through the air conditioning outlets. The water valve is now open, allowing full flow through the heater core, heating it to coolant temperature. Outlet air temperature is regulated by positioning the blend air door with the temperature lever to divide the flow. Now, in the vent position, outside air enters, and the blower forces the air through the evaporator. However, the air is not cooled by the evaporator because the compressor is not engaged in the vent position. Air moves to the blend air door. By positioning the blend air door, outside air can be heated because the water valve is in the open position and the heater core is at coolant temperature. The mode door then directs vent air to the air conditioning outlets, and the heat defrost door is in the up position. In the heat position, the air inlet door is open to outside air. The blower forces air through the evaporator, which is not operating because the compressor clutch is disengaged. Air travels to the blend air door, which directs air through the heater core, and to the mode door, which allows heated air to flow through the heat outlets to the passenger compartment. In the heat and defrost modes, air inlet and mode door positions are identical, but in the defrost mode, the refrigeration system is operating to remove moisture from outside air entering the car, and the defrost door is directing most of the airflow to the windshield area, with bleed air traveling through the heater outlets. It's necessary to know the correct position of each door for every push-button position when you're checking operation in the air distribution system. This information is covered in detail in the reference book. The air conditioning electrical control circuits operate on electrical feed from 2 fuses in the fuse box. One fuse protects the compressor clutch circuit and the other the blower motor control circuit. The blower speed control resistor block is located on the passenger side of the evaporator and heater housing. Additional information on the electrical circuits can be found in the reference book. Our next session will include detailed coverage of procedures for performance testing of all Chrysler air conditioning systems. This review of the Aspen and Volare blend air system airflow and controls should help you keep these systems operating at the peak levels they were designed to produce. And of course, keep your customers comfortable.